Hello, and welcome to today's virtual event. My name is Dr. Danae Fullwood, and I'm your host here at NASA's Johnson Space Center. Today's special event is about artificial intelligence, or AI, and how NASA is using the powerful tool to progress humanity's exploration and understanding of the cosmos. AI has quickly become a part of everyday life, helping as a virtual assistant for daily tasks, working as a tool for scientists, and shaping the careers of tomorrow. We ask students around the world to send NASA their questions about AI, and we love seeing all the really thoughtful ideas. In just a minute, we'll chat with a NASA AI expert who will answer those questions. But first, to get us started, here's a short video to introduce you to how NASA is using AI.
Artificial intelligence, or AI, is when computers or robots are built to think and learn like people. AI tools can solve problems, make decisions, and even learn from experience. You might already be using AI technology for things like homework help, generating study guides, or maybe to create silly images. Here at NASA, we're using AI technology too. Our researchers and engineers have actually been using artificial intelligence for decades.
My name is Martin Garcia, Jr. I'm the AI Adoption and Innovation Lead for the agency. My job at NASA is to help adopt tools across the agency to make people more efficient, but also innovate with those tools to progress in our mission.
The Perseverance rover on Mars uses AI to drive around all by itself. It takes pictures of the ground, figures out where rocks, holes, and other rough terrain are, and then decides the safest path to drive. Scientists at NASA use AI during natural disasters like hurricanes or wildfires to analyze satellite pictures and provide support to disaster relief efforts. AI technology also helps find planets outside our solar system. Scientists train AI models to analyze vast data sets from deep space telescopes for patterns that indicate planetary bodies. We've discovered many new planets this way. NASA is always investigating new and efficient ways to use AI to support the agency's missions and goals.
We can actually leverage AI on the Artemis missions for supporting the habitats the astronauts are going to be in, the lunar vehicles that they're going to be using, but also supporting in astronaut health. We are looking at using computer vision to help look for damages or identify damages in different parts of either the astronaut spacesuit or the asset that they're currently in, the environment that they're currently in. So there's many ways that AI could help.
There are even ways you can help NASA utilize AI technology through the agency's Citizen Science program.
I'm Megan Grace Lee, and I'm the lead researcher of the NASA Citizen Science project, Are We Alone in the Universe? I'm building an answer key for my AI that's something like 100,000 questions long, and I need a lot of help with this. Every single question has to be looked at by a second, third, at least 15 extra pairs of eyes. This is where the volunteers come in. Anybody with internet access can join, and I love sharing the opportunity with everybody else.
From sifting through scientific data to exploring the unknowns of our solar system, NASA will continue to utilize AI for the benefit of humanity and to inspire the world through discovery.
Wow, the agency is truly doing incredible stuff with AI. And now here to answer your questions is Martin Garcia himself. Hi, Martin.
Hey.
And here to read student questions, we have Karim Megji, CEO of Code.org. Hi, Karim.
Hey.
Martin is NASA's AI Adoption and Innovation Lead. In this role, he comes up with new ways to integrate cutting-edge AI technologies into NASA's operations. Karim is Chief Executive Officer of Code.org and previously served as its Chief Product Officer. Code.org's mission is to expand access to computer science and AI education, and to bring high-quality, equitable learning opportunities to students worldwide. I can't think of two better guys to come together to talk about this. So with that, Karim, take it away.
Thank you, Danae. Our team at Code.org partnered with NASA to ask students what they wanted to know about AI from a NASA expert. We got some really interesting submissions. Martin, you have a really cool job. Did you know that?
Yeah, thank you. I appreciate it.
So we're going to jump into some student-submitted questions, and the first one's a great start. So how long has NASA been using AI?
So NASA's been using AI for decades. It's been a long time. It's just now it's more scalable and capable than ever before. It's able to learn. It's able to generate designs in ways that it wasn't able to do before. So it's an exciting tool for us to leverage at this point in time.
That's very cool. So it's been around for quite a long time. AI is not just the last 3 years.
No, I think probably since the 60s, probably around that time frame.
Oh, very cool, very cool. Yeah. So I'm sure a question that's on a lot of students' mind, how did NASA use AI on the Artemis II?
So we have to be really careful when we put new software on spaceflight hardware, especially when humans are on board. AI played a supporting role where we used simulations to test out Artemis II telemetry data, things like that, in a simulated environment to look for any problems before they actually ever happened. So it was a supporting role, but yeah, that's where we are right now with that.
So was the AI actually on board the Artemis?
No.
No, okay, so the human was in control in that situation.
Exactly,
Yeah.
so that's one thing we want to emphasize is, there's always like a human in the loop for these type of things for the verification and validation process. We want to make sure that the output is good to go before we try to actually use it anywhere within operations.
Yeah. Makes sense, makes sense. So our next student question is, how does AI help the hunt for habitable exoplanets?
Yeah, so AI is really good at pattern recognition. So it analyzes a lot of data and habitable planet data, right? And what it does really, it helps us find, essentially gives us a map of where to look and focus on so we can be more efficient when we're trying to find these exoplanets. It's a really good research opportunity for students that want to learn more about exoplanets, AI, and discover how to leverage and combine those two fields. It's wide for research right now for students to get in there, dive deep and learn a lot more.
Very cool, very cool. What's an exoplanet?
An exoplanet is a planet that's outside of our solar system.
Okay, cool. I didn't know that, so.
Yeah.
So the next question a student asks is, does AI help NASA autonomously navigate spacecraft in deep space?
It does. It's pretty cool. We have a rover called Perseverance that's currently on Mars, and it navigates from one place to another, but it uses AI to try to avoid obstacles so it doesn't get stuck or damaged. Some other things that we're looking at in the future is to see if we can use AI to help us find landing zones that are safe for spacecraft. That's further down the line, but research that we're looking into in another way to leverage AI in space.
That's very cool. So how does AI work in the rover if the rover makes a mistake? Let's say it bumps into a rock.
Yeah, so there's a validation and verification process before we actually put software on any hardware, especially that's going into operations. We want to make sure that we understand the requirements, the constraints, and the expected outcomes of AI before it goes into operations. And that process was done within the Mars rover, so we know what to expect. If it does make a mistake, which, hey, anything's possible, right? We take that information and we go ahead and update that information and we teach the model to not make that mistake again.
In that time, how do you get it unstuck? So let's say it's bumped into a rock. What happens then?
Yeah, I mean, we have tools within the rover to actually pull itself out of things, right?
Yeah.
There is a command and control section where we can actually move it ourselves, right? But that's we got to dig ourselves out, basically.
Yes, but so the human can step in and kind of redirect the machine in that moment. Yeah,
absolutely.
That's very cool. All right, well, let's go on to the next question. So a student asks, humans explore space partly because of curiosity. Can NASA design AI systems that mimic curiosity to explore unexpected things instead of only following mission objectives?
Curiosity. It's a curious question.
Yeah, it's a very curious question.
It's good. I would say maybe in the future. AI, we're just not there yet with AI. I know there's some research going on in that field right now, but the thing is, AI doesn't think like humans, so we're just not there yet. It's really good with pattern recognition and understanding systems and processes, but yeah, it's just not there to replace human curiosity or the human think tank that's within all of us.
Yeah. So in many ways, AI is there to like help us find our curiosity, amplify our curiosity, maybe satiate or fulfill kind of the things that we want to learn or know more about.
Yeah, it's a tool. It's a tool for you to use, kind of like you use your calculator.
Yeah. Yeah, I like the point about calculators don't have curiosity.
Exactly.
A car doesn't know where it wants to go unless a human sits behind the wheel and takes it to destination.
Exactly.
Yeah.
You got to have that input, and you have to verify that output.
Yeah. So, is AI used in the actual design of rockets and spacecraft?
Yeah, in some cases it is. We leverage a lot of digital twin simulations, and digital twin is basically like a virtual representation of a piece of physical hardware, let's say. And yeah, we run simulations. We combine that with AI, and really just do like what if analysis. And with that, we can test out whether or not a spacecraft can be put together properly. Another thing that we're using is machine learning, which is a way for us to actually, machine learning is a way to kind of teach a piece of software to know how to do something, let it make mistakes, run the analysis again, show that it made a mistake, and then you keep on looping that until it realizes that it's what is the correct way of doing things. So one of the ways that we're using machine learning is for welding, actually, right? Are we actually welding pieces of the spacecraft together properly? And how we're using computer vision and combined with machine learning to be able to verify that the weld is correct, reliable, and strong to be able to support all the liftoff that may happen.
Yeah, I appreciate that you talked a little bit more about the difference between machine learning and what a lot of students might be experiencing as AI today. Machine learning really helps you focus on the machine learning about a particular task.
Exactly.
Example like welding, and then putting that into simulation. One question that may be on students' minds is, do you use vibe coding at NASA?
Yeah, we do. I would say that in NASA, it's more. Well, vibe coding, what vibe coding is, and maybe you have a better definition than I do, but the way I look at vibe coding is like, hey, you know what? I feel like building something, but I may not have the exact expertise to do it. But there's AI tools for us to leverage today to help us accomplish whatever we feel like doing. So it's like your vibe, what you feel like doing. At NASA, we do that. We have a certain set of approved tools where we can vibe code. But they've had to go through an approval process, make sure that we understand that it's secure, it's safe, and we're actually making sure that we understand the origins of the software. While vibe coding at home, I just go to X website or whatever and just go ahead and download a model and test it out and do computer vision or text to speech or whatever generative AI software out there for free. I do vibe coding and testing at my home computer. But NASA's a little bit more strict on how they can do vibe coding, but it is done.
And I would assume, actually, when you do vibe code for NASA, because it's so important that the software that you're producing is right and high quality and works, you must evaluate the outputs from the AI models, like look at the code it generates, make sure that it fits the requirements, fits the constraints, whatnot. Talk a bit more about that.
Yeah, again, it goes back to that validation process, right? You own the requirements, right? You have to understand the requirements, you have to understand the constraints, and you have to understand the expected behaviors and expected outcomes. Those are all things from a foundational perspective as an engineer you need to think about as you're using these tools. Again, it's a tool. It doesn't have accountability. AI does not have accountability. You as an engineer, you have the accountability, you have the ultimate judgment, so you need to validate that output.
Yeah, that's great. Well, that leads to the next student's question, which is, how is AI reshaping engineering careers, and how can engineering students prepare ourselves for the future where we need to use AI?
Yeah, that's an interesting question. So my background is computer engineering, and at the time it was kind of new. And what that is basically a combination of electrical engineering and computer science. So now I think that's going to happen more and more often with the other domains like mechanical engineering, chemical engineering. I think the way these engineers can prepare themselves for the future is to kind of get their experience points up with software skills. If they do that, I think they'll be able to take advantage of AI they can take advantage of AI the best way they can for their particular domain, right? You got to take advantage of AI. Right now, if you don't, then you may be falling behind.
Yeah, I love the point you made about sort of foundational computer science is something that kind of raises that ceiling for our use of AI across all disciplines, even beyond engineering. It could be space exploration or biology or, marine sciences.
Construction, maybe in
Construction,
the future,
yeah.
right?
You talked about
never
welding.
know,
Yeah, you talked
right?
about welding.
Absolutely.
Yeah, that's great. That's great.
Yeah.
I know something that fits in with your job, which is using AI to gather information. So what checks ensure the accuracy of its answers?
Well, ultimately, it's the human. It's the human that does that kind of final check. There's that verification. There's that validation process. The AI software, and let's say generative AI, will analyze a lot of data, and give you some information. But you got to make sure that, one, the data is correct. Two, the information that it's outputting is actually representing the data that it collected. So there's a verification, validation process with human in the loop to make sure that the output is accurate.
Yeah, the human's so important in these processes when working with AI.
Absolutely.
Yeah.
AI is there to augment, to help the human, right? And so that's again, it's a tool for us to leverage. That's very powerful.
Great. Well, let's move on to the next question from a student who asks, does NASA use generative AI? If so, which specific tasks get taken care of by it?
Yes, we do. We're using a lot of generative AI now. It's there for analyzing data. It's there for some brainstorming some ideas. It's there for let's say coding support, right? But I would say we're definitely using it. But the second part of that question is I give a specific task. The imagery work. Generative AI is really good when you combine things with other tools. For example, combining generative AI with computer vision. The machine can not only look and validate what objects are within an image or a video, but with generative AI, it can describe it, right? It can make it searchable. So these are things right now that we're experimenting with, and it's being done across the agency. So it's a powerful tool for us to leverage. I think really at this point, the only limitation we have is our own curiosity, our own imagination.
Yeah, talk a little bit about how you use AI in your work as a thought partner to help you think through problems.
Yeah, I mean, I use generative AI to again, I give it kind of the requirements, the constraints, some of the background context of what I'm trying to do, and I go through the process and I'm brainstorming back and forth with generative AI, and it gives me some really, really good ideas, things I haven't thought of, but it also can give you some bad ideas. It's not perfect, so that's why it's up to you as the engineer to have that judgment, have those fundamentals that you learn in school, the math, the physics, and make sure that you understand that AI won't be 100%. It's not 100% right now, and especially in the generative AI use cases. So yeah, I think that's an approach that we're doing. That's how I brainstorm, and I think generative AI is a powerful tool.
Yeah. I like the point you made about knowing what the requirements are, understanding the constraints, what's the goal of the thing that you're trying to do with AI in that moment. It helps you evaluate the outputs and understand when it's right and when it might be actually wrong.
Exactly, and that's where your fundamentals come in, right? To make sure that you can pick that up. Like, that doesn't sound right. Gravity's still 9.8 meters per second squared, right?
Yeah. I'm glad you know that.
Okay.
Well, let's go on to the next question. As an engineer, how do you use AI without it becoming a crutch?
Yeah, I mean, that's a good question. It can be a crutch if you rely on it 100% of the time, and that's why I think the fundamentals are so important, especially from an engineering perspective, but from a student perspective as well. If you have it doing your assignments, your homework all the time, you're not actually getting the most value out of your own important mind, your own thinking, right? And just relying too much on AI, and then it becomes a crutch. From an engineering perspective, we look at it from a validation and verification process. We want to make sure that we're understanding the requirements, the constraints, and expected behaviors, test that out before we actually put anything into operations.
Love it. Yeah, it's so important for learning to not depend on the AI to actually get that learning. AI can help you with the learning, but it doesn't learn for you.
It's a tool.
It's a tool. I think this is a really interesting next question from a student, which is any AI computing done locally on the spacecraft's hardware while in space, or is it all on Earth?
Yeah, and it's actually both. I mentioned earlier about the Perseverance rover, where it's using AI currently to be able to find, get from one place to another while avoiding obstacles, so it doesn't get stuck or basically, it doesn't get damaged. So that's one use case of how AI is being used in space, specifically on Mars. There's one use case that there is some research going on right now with that, where we have satellites that have AI on board that collects the data and it analyzes that data and then sends back to Earth the relevant data of what we wanted. So instead of just giving us a bulk load of, like, it collected all these, let's say, images of Earth, but we only want to see, red rocks or something, then it's going to give us everything. It's going to give us just the red rocks, right? So AI is going to be, it's really, really good at picking those things up, and that's something that is being used in space right now.
That's amazing. It's kind of like the eyes of the human who built that AI system to only select the things that human cared about.
Exactly, and and plus, we're getting to the point where we're having like a data problem, a storage problem, right? So it's getting so much data. Like, what do we keep? What don't we keep? Can we automate that?
Yeah. All right. Well, our final question from a student is, what is the most significant way AI has impacted NASA in the past few years?
In my opinion, I think again, back to the data and analyzing. We have a lot of data, and we're going to get a lot more data with the future Artemis missions, right? We're going to get missions on the way to the moon, around the moon, when we land on the moon, and we're on the lunar surface exploring. That's going to be really, really exciting, but it is a lot of data to go through, and AI is going to really help us with that, and I think that's where it's going to be most impacting us. The other thing, I think, from a technical perspective, is combining digital twin technology, digital twin simulations with artificial intelligence to test out hardware in a virtual sense, and do what-if analysis and testing and look for problems that may or may not be there before actually doing something in the physical world. So I think those are really big and impactful things that NASA's leveraging with AI.
Yeah, it seems like NASA's been using AI in a lot of different parts of the activities of the organization, from building rockets to exploration to data collection to image collection. Literally, it seems like the entire cycle of going to space has some form of AI involved, but always with a human steering it.
Absolutely. We want human in the loop. Again, AI is here to augment the human. It's a tool for us to take advantage and make us more efficient in our current and future operations.
Well, Martin, that's all the time we have today to answer students' questions. Thanks for taking us through a journey on how NASA uses AI.
Thank you. It was really good questions. It was a lot of fun.
And a big thank you to all the students who sent in questions. We at Code.org love partnering with NASA to inspire this generation of students working with AI in space and beyond.
Thank you, Martin and Karim. If you're feeling inspired to get more involved with NASA and AI, NASA has opportunities for you. NASA's missions are collecting more data than ever before. Telescopes, probes, and spacecraft, they capture millions of images and measurements every day. Scientists have two powerful tools to help sift through all that data: artificial intelligence and citizen science volunteers. Before AI can help scientists comb through that data, it has to be trained with examples humans have labeled. Volunteer citizen scientists help create these training sets and check AI's work. And that's where you come in. NASA's citizen science projects invite anyone to help with real research. No experience needed. You can help look for signs of intelligent life in deep space radio signals, spot asteroids near Earth to help protect our planet, or even find distant galaxies to learn about dark energy. Citizen science projects let you do real science, meet real scientists, partner with AI, and contribute to discoveries that may even change how we understand our world. You don't have to be an expert. You don't need special tools. You just need your curiosity. Visit NASA's Citizen Science website to get started. Thank you all for joining today's discussion about AI at NASA. and never, never stop exploring. Signing off. Bye-bye.